In 1966, an entire mountainside didn't explode. It didn't collapse like rock. It suddenly behaved like a liquid. In less than 5 minutes, around 140,000 tons of coal mining waste rushed downhill and buried Pantglas Junior School in the Welsh village of Aberfan. 144 people were killed, including 116 children. The terrifying question wasn't why the hill fell. It was how something that looked solid suddenly flowed like a deadly black tsunami. The answer lies in a phenomenon called thixotropy. Some fine-grained materials can appear stable and solid while undisturbed, yet lose much of their strength when subjected to movement or shear. Coal waste contained fine shale fragments, coal dust, and other loose particles. When relatively dry and at rest, friction between those particles helped the spoil heap hold its shape. But if enough water entered the material, that internal structure weakened dramatically. Under increasing stress, what had behaved like a solid could begin flowing much more like a viscous fluid. That is exactly what happened at Coal Tip 7. The spoil heap had been constructed over known natural springs despite repeated local concerns about water emerging from the hillside. Weeks of persistent rainfall added even more moisture. Water filled the tiny spaces between the particles, raising pore water pressure while reducing the friction that kept the slope stable. The heap looked unchanged from the outside, but internally it was losing strength. Eventually, a small movement was enough to trigger a much larger failure as the saturated mass rapidly transformed into a flowing debris slide. Once motion began, mechanical shear spread through the saturated waste in seconds. The flowing mass accelerated downhill at roughly 20 miles per hour, carrying enormous momentum as it overwhelmed everything in its path. Aberfan became one of history's most devastating landslide disasters, not because nature was unpredictable, but because hydrology, geology, and slope stability had been ignored. The lesson still shapes engineering today. Solid ground is only as stable as the forces holding it together. Ignore water beneath the slope, and the earth itself can begin to flow.